Okay, good morning, everybody. Thank you for joining this webinar organized by the ECEM team. So we are still waiting for some people. We had more than 60 people registered for this session this morning. Some are still missing, so we'll wait. Yeah, it's 9:28, so we'll wait for 2 or 3 minutes, and then we'll start directly the webinar. I will say it again in a few minutes, but all your microphones are muted to avoid any problems and interferences. But you have the chat option in the control panel that you can use to send a message to the organizers, and you also have a questions panel in which you can ask questions on the fly during the presentations. So I hold on for a couple of minutes, and then we'll start. Romain, excuse-moi, mais je fais un webinaire avec 60 personnes, ça t'embêterait de laisser fermer. Merci, désolé. Okay, so we'll wait for an extra minute and then we'll start. Okay, so I think now it's time for starting the webinar. So once again, good morning everyone, and welcome to this webinar organized by the ECEM team. I will say a few words about it in a minute. So there's one session this morning and there will be one other this afternoon. So this webinar is organized by the ECEM Copernicus project. So ECEM is for European climatic energy mixes. It's one of the sectoral information system proof of concepts developed in the frame of the Copernicus Climate Change Service program. This ECEM project has started 10 months ago and will run until the end of 2017. And we thought it was important to have this webinar because there was one a similar one in the US based on the use of the mirror reanalysis for wind energy. And we wanted to replicate this good idea here in Europe to talk about ERA-Interim. So the Copernicus ECEM project is basically aiming at developing a proof of concept of climate service for the energy sector. I won't go into the details. You have the email address there, and it will be available. It's available on the web, so you can have a look at it. If you are interested, you can contact us, of course, to get some more details. I would just like to go very quickly through the agenda. We will have, so it's a one-hour webinar. We'll have 3 presentations. The first one from Hans Herbach from ECMWF, who will give an overview of ERA-Interim. Then we will have Jill Lascano from Vortex, who will talk about the use of ERA-Interim for the wind energy sector. And then Lucia Mal from Minparitech, who will talk about the use and the assessment of ERA-Interim solar radiation. Then we will have a 15 minutes question and answer session. And you have probably seen that there is a question panel in the control panel of the GoToWebinar software. So you can ask your questions on the fly, and we will try to answer as many of them as possible in this 15 minutes time. Please notice that there will be a second session of the webinar this afternoon at 4:30 p.m. European time. It will be shared by Alberto Troccoli. And I forgot to mention, sorry, but my name is Laurent Dubu, and I'm working with EDF, so the French power company, in the research and development direction, and I'm one of the partners of the ECEM project. So the webinar is recorded, and it will be available on our website soon. Okay, so we'll now start with the first talk by Hans Herbach. I just need to give him the lead on the presentation. Okay, so Hans, you know the presenter. You should share your screen and you can start your presentation. Thank you for 15 minutes.
Okay, thank you very much. So I will give an overview of ERA-Interim, and I'll also say a few words about ERA-5, which is the follow-on of ERA-Interim. So my name is Hans Herbach. I'm the team leader of the Reanalysis team of the Copernicus Climate Change Service, which ECMWF is operating on behalf of the European Union. Okay, so why are we doing reanalysis? So what is the rationale? One of the rationales is that it's consistent. Whereas if you look at the operational forecast system at ECMWF, and when you look at the functional forecast score, that's a very popular way for us to assess how good our system is. Very important. And then you see over time, there's a top left panel, right panel, you see over time there's a massive increase in forecast score, and it's partially due because the model is changing, and so there's not to be consistent. So certain physical processes that were in the 80s not well represented, and they are very well represented now. So if you're interested in a consistent data set, for instance, you want to train your algorithms to know what the climate is, the wind climate is, or what the extremes are, what can you expect, and you want to look at the 30 or 40-year archive, then the operational ECMWF model is probably not the best solution, although it gives the best forecast system at this moment. So that's why we have reanalysis, so consistency. So we fix the model, so we keep the same model for the whole period. We do, of course, ingest as many observations as we want, which means that in the past we had less observations than now. So there will still be a change in the system, but it will be much smaller, and that is reflected on the lower right panel. There you see the corresponding scores for ERA-Interim, and they're much flatter. So it means that the system is much more stable in the sense of quality. Okay, so we're using We're using the ECMWF system, analysis system, and in this way we can merge observations into global fields. So we have information at each grid point rather than just having it scattered around in observations, using the laws of physics. We also apply appropriate bias correction schemes because observations are biased. And as I said, we maintain the same system for the whole period. And of course, we do it at a lower resolution because it has to be affordable. Okay, so a small overview of all the reanalysis that have been atmospheric reanalysis, because I will talk only about atmospheric reanalysis that have been performed all over the world. So it all started around 1979. Then there was a first reanalysis round, ERA-15, ECEM-WF, then ERA-40, JRA-25, ERA-Interim, third round, JRA-55, MERA. Then now a fourth round has begun, so MERA-2 is available, and ERA-5 is now in production. And JRA-3Q is planned for the next year. That's JMA. Okay, so overview of all the reanalysis that have been or are being performed at ECEM-WF. So ERA-Interim is here. So we have, first of all, the atmospheric and land reanalysis. Of course, ERA-Interim also includes ocean waves. Then we also have ocean reanalysis. Last 2 years, we also have been working in light of two European projects called ERA-Clim and ERA-Clim-2 in 100-year reanalysis. There we only use surface observations and not the full observing system. Then we have also had enhanced land product, for instance, for ERA-Interim, there's ERA-Interim land, and atmospheric composition. So at the end of the talk, I will say something about ERA-5. Okay, so overview of ERA-Interim. So you can find all the details in this paper. So it's an open paper, it's a quarterly journal, 2011. So the start of the production was August 2006, based on a ECEM-WF cycle, integrated forecast system cycle, IFS 31R2. So then the model boundary conditions of SST, CIs are used as in our operation, as they were used in operation, so which is slightly inconsistent because the SST has, the choice of the SST has changed over time. Then the spatial resolution is 70 kilometer global. We have actually spectral model, so with 255 components around the globe, but that works out about at 79 kilometers globally. There's 60 levels in the vertical. From 10 meter, that's the lowest level up to 10 Pascal. Then the output frequency is every 6 hours for analysis, but we also have short forecasts linking these analyses, and they are available at a resolution of 3 hours. So the time period is available from 1979 onwards, and we are now in a kind of, well, we have monthly updates. So typically we update with a delay of 2 to 3 months, and at the moment June 2016 is the latest month available. So as I said, we're using the ECEM-WF data simulation system, which is 4D VAR, and we're using in-situ observations as satellites and we apply all kinds of bias corrections for satellites. Okay, this is just to give you a flavor of the observing system. So this is not so these are just the satellite data, but not the in-situ. So you can see there's a whole range of observations going into ERA-Interim. And of course, they're not all sensitive to, for instance, wind, but surface wind. But 4D VAR it combines observation in a multivariate way. So it means that temperature observations, humidity observations, they will have in some way they all regarded consistently, and they will have an effect on wind, on radiation budgets. Okay. So ERA-Interim is freely available, so you can download data from our web portal. So there's two ways. You can. This is one example which you can click and download data, but you can also use a web API where you want to retrieve more data, or for instance, in a more where you want to download data every day in automated way. So there's a lot of parameters available. And over a long period. And it's available at full resolution, so at this 79 kilometers. Okay. So ERA-Interim is used worldwide, and we have more than 30,000 registered users. So this gives you an idea of the number of users we had in 2015. Well, we're using for C3S at the moment. We are using ERA-Interim for monthly updates of the climate, and so each month we update this page. You can find it at climate.copernicus.eu. So this is one application of ERA-Interim. ERA-Interim clearly shows the warming over the period since 1979, and also the records we had in July 2000. July 2016 was the warmest month on record in absolute sense. So now I will say a few words about ERA-5. So that is the follow-up for ERA-Interim. We are in the early stage of production. So it will be based on a 2016 system rather than 2006 for ERA-Interim. So there are a lot of new physics and developments going in, and a lot of more satellite data will be assimilated. Then this resolution is 30 kilometers rather than 80 kilometers, on 37 levels on the vertical rather than 60. We have an improved radiation scheme, including CIMIC 5 forcing, which will take account of the evolving climate. We're using more consistent SST and sea surface, SST and sea ice products, and we'll use a number of new and reprocessed satellite data records. The output will be hourly. We have more parameters, such as 120 events. And we also have an uncertainty estimate. And on top of that, there will also be a land surface analysis, which will not contain surface winds, but more things like soil moisture at a 9 kilometer resolution. Okay. So as I said, reanalysis is a compromise between resolution and consistency, because we cannot afford to run a resolution of the operational ECEM model at the moment, which is 9 kilometers, going back to 40 years. But consistency for reanalysis is very important. So this gives you an impression. This is one example for a tropical cyclone Halong in August 2014, and in black you see the minimum sea level pressure by observations are the points. Black is ECEM operations. ERA-Interim is the green one, and ERA-5 is the blue one. So it will be quite an improvement. Okay, so in conclusion, ERA-Interim is standing the test of time reasonably quite well. Of course, ERA-Interim is aging. It's not able to ingest all the observations that it could be at the moment, but it's still very good reanalysis. It's available from 1979. We have monthly updates with a 2 to 3 months delay. So currently, June 2016 is available. The production of ERA-5 is well on the way. We will make available a test data set very soon, and hopefully we will have finished the complete production at the end of 2017. And of course, some point ERA-Interim will be discontinued, but it should be at least 6 months after completion of ERA-5. Okay, thank you very much. That's all I have to say. Thank you very much.
Yeah, and thank you very much. Could you please turn on your microphone until the questions and give me back the so from one presentation to the other. So we will
Okay, yeah, sorry, I had a small problem. So Gilles, you are not the presenter, and you will talk about the use of ERA-Interim for the wind industry.
Okay, thank you very much, Laurent. My name is Gilles Cano. I work in Vortex, and I will give you an overview of how we see the reanalysis and in particular interim from the wind industry. So first, I would just like to introduce the company I'm working, because it's an example of one of the users of the reanalysis. In our case, we use the reanalysis to drive our mesoscale model WRF, that is our engine to downscale the atmospheric conditions up to the resolution that is required for the wind industry for some of the assessment that are needed, because wind industry need very localized information of the wind resource conditions. That's why we use the reanalysis to drive a mesoscale model to resolve almost the wind condition up to 100 meters. Here, so the kind of product we use based on the downscaling that is driven by the reanalysis is like a virtual time series over 20 years back in times, analysis of wind conditions at very high resolutions. We also convert the time series into power time series to get some index of productions and other kind of products that are required for the industry. So what I'm going to talk now in the next 12 minutes is basically just to give you an idea of how we use the reanalysis, how we do the quality assessment within the wind industry. This is very important. I will show some results from our validation exercise of the reanalysis, and then I will end with some conclusions on how we should work with this data, because we don't have to forget that these are model data, so there are some special requirements for the use. So how we use the reanalysis, I'd say, is one of the main uses to drive the mesoscale models that are like weather models, to provide virtual time series, to provide information for green field analysis. This is when we don't know exactly how the wind resource is distributed, so we have like a first guess using the output of a mesoscale model. We do also large assessment for regional mapping, and then we can even port the model up to very high resolutions to resolve the wind farm distribution of the results. But also we use the reanalysis from the source as a pure virtual time series, so without any downscaling. This has been one of the major usages by the wind industry, and one of the success in the last year of the ERA-Interim, MERA, in the application for real projects. So the reanalysis is real, especially the last generation of reanalysis with ERA-Interim, MERA, CFS, CFSR, came to provide information for a global market that need information everywhere, every time for projects that are developed everywhere. So the use of the reanalysis has been justified because the correlation with observation is high. It justifies the use. An example of the use of the reanalysis is, as it says, to use it as large-scale conditions for the downscaling products. It's been employed now, the virtual time series, even in feasibility report that are accepted by the banks. Reanalysis and downscale products are used in many tenders all over the world. We see many publications in the wind industry that use the reanalysis as a background information, and also we see that in the specialized forum in the industry, we have sessions only dedicated to mesoscale modeling, and that's included also the reanalysis, because it's the fourth thing that we need. So, but we have issues, of course. No one is, for instance, as we use the reanalysis for long-term validation, we probably need more validation with long-term data. It's very difficult to get long-term data to validate the reanalysis, because for the wind industry, we we require that these long-term data are based on using the wind industry standards in terms of measurement. So it's not very easy to get like 10 years of high quality wind observations. Another issue is whether the reanalysis are consistent over time. This is one of the question that came more often from the users. Another question that came is which is the uncertainty and error of the reanalysis. It's very complex to provide an answer for every situation we face with the reanalysis in projects in different regions with different climates and different complexity. Also, another question is how we use the reanalysis with the observation. Of course, we have a model product, that is the reanalysis, and we have observation on site, how we combine both. Also, another question that is very recurrent is, okay, I have few reanalysis sources, how I work with both, with ERA-Interim, MERA, and other products, how we can get the maximum information with different sources. And also there are other questions more in terms of how to bring more climate knowledge to the wind industry, and also how to deal with the transition between projects. This is something that we saw when MERA went offline, and then the industry need to adapt to MERA 2, and the same thing is going to happen when ERA-Interim is going to be offline, and the transition with ERA 5 needs to be smooth. So comments on the reanalysis. This is from a perspective from the users. We see that from the main reanalysis that we have at the moment, MERA and MERA 2 has been much more success in the use for long-term reference. This is something more that came from how it has been adopted. In terms of using the reanalysis to driving condition for mesoscale scaling, ERA-Interim is being employed quite often. In terms of popularity, we see that MERA came a little bit more popular within the industry. Also, ERA-Interim has been very employed for offshore, because results has been very positive in the use of ERA-Interim for offshore market in Europe and North Sea. In terms of consistency, there are issues that came from our experience. For example, north of Chile, northeast of Brazil has been a very tricky region in terms of the consistency for MERA, and has been probably sorted out in MERA 2. ERA-Interim has been some issues with south of France in terms of consistency for long term. And another question is for probably the MERA 2 show us that the transition between two projects needs to be done smoothly. And my personal opinion is that probably ERA-Interim could be as popular as MERA, but probably came a little bit late. So maybe ERA 5 it will probably now have to learn from this experience. So in terms of regional issues that we found in our experience with the reanalysis and downscale product, we see that the reanalysis itself has some problematic in North Chile. That is a region that we have a strong market development. There were some issues with the monsoon shift. Brazilian Northeast, that is a very important region in the development of the market, have some kind of issues with the direction of the winds. In general, the low-level jet is underrepresented, and obviously the high mountains regions are very complex. Some of these issues are resolved with the downscaling, but still we need there are some improvements that need to do. And also the amplitude of the stream events is also that needs to be it's something that sometimes needs to be fitted, because reanalysis tends to provide the streams that are not really appropriated to all the sites. And also, well, the consistency is a very complex issue. There is a discussion, an open discussion, whether the consistency is natural, is related to change in the variability of the climate, or is driven by artificial change in the observed system that are behind the reanalysis. So just how we do the quality assessment is in terms of the use of the reanalysis. Most of the users of the reanalysis by itself is just as a virtual time series. So what we want is the reanalysis to match the survey data in terms of the correlation. So we the industry tends to use as a metric the correlation factor. Probably we could say that it's a very simplified metrics, but it's a very easy to understand and easy to compare. So it's something that it's almost the standard that is employed by the users. So in terms of the use of this correlation, it's important to know what we are measuring. Sometimes we use only 12-month data observation to validate the reanalysis. So sometimes it's difficult to see with the data we have to see more than one annual cycle. So it's the main driver of the ERA-2 in the validation we get from the users. So yeah, outcomes from our validation, I will show results from 240 sites all over the world. The model data we employ is ERA-Interim. I will benchmark ERA-Interim from the downscale we use internally in Vortex with 3 km resolution, and we compare with MERA. And I don't use it MERA-2 because I don't have all the sites that I have for MERA. Soon we will have all the sites at 3 km, but this was like to make it consistent, and we validated again the data from the wind industry that has the usual standards in terms of measurement, height, anemometers, etc. So if we try to have a global picture, we see that the median value of ERA-Interim is for daily and monthly is in the range of as MERA, a little bit lower in terms of the median for ERA-Interim. And the main difference with the downscaling, that the downscaling is providing more resolution, is that many sites that are not really very well represented in the ERA-Interim or even in MERA that are somehow recovered by the downscaling, so we get a decent correlation factor. So that's the main reason. The main difference is especially there is when we are working in sites that the reanalysis is not properly representing the conditions. So if we want to see how this correlation factor are distributed in the site I show it, I try to aggregate all this. I aggregated all these sites in terms of 5 points. So we try to get like a mix between the local information and the regional information. So we see that in general there is like a good this is for the downscaling using ERA-Interim. We get like values above 0.8, that is probably the recommended threshold for use of the data, but still we have some regions that the representation even with the downscaling is not satisfied, like we see in South Africa, like we see in Mexico, and even in some sites apart from this. So still there is a scope to improve the representation of the site, because even with the downscaling up to 3 kilometers, the correlation is not enough. But what on the other hand, we see that most of the sites are very well represented. So this is a positive perspective of this. So if we try to apply a selection criteria, that will be when I can use the data, the model data for my as a long-term reference. If we say that the ERA-2 should be above 0.85 and the daily or above 0.75, this is it's subjective. It's not there is no standard on how we define this selection criteria. We see that with the downscaling, we for all the sites over the world, we get the downscaling get almost 70% of the sites can be employed for as a long-term reference. And this is very important because when in these 240 sites we employ, they are very complex sites in terms of the climate, in terms also of the wind conditions, because the topography, because very localized effects. So this is a very good result in terms of the use. If we obviously concentrate in just one part of the continent in Europe, for instance, that is one of the more mature markets in terms of the wind industry, we see that we get with the downscaling, with ERA-Interim, we get almost 90% of the sites are very well represented and satisfy this selection criteria that is a strong selection criteria. So two last slides, we can say that from the wind industry, the reanalysis is already adopted. Obviously there are some improvements that are needed, and we hope that with ERA-5 we will get better results in this region that still are very weak in terms of their representation. The perception by the industry is positive on the use of the reanalysis and the downscaling product. This is very important. And what's something that the reanalysis made us possible here in the wind industry is to do our analysis in the time domains. This is something that is very important because it gives us much more information and not only average statistics. Yeah, and then, just as the last slide, just from the user perspective, there are many aspects that we need to do, not just in, the improvement that we will get from new reanalysis need to come with also improvement in the use of the data. So we need to understand that these are model data. We need to understand that the consistency is not because there is a change in the variability that is not consistent. I think we need to dig inside which could be a climate driver for this change in the variability. One question that is very recurrent within the wind industry is how many years I will need to use. My answer is always to take at least 20, because then you will get more extreme events. But people are sometimes reluctant to use a lot longer than 10 or 15 years. Obviously, the question that comes is, okay, now we have few sources of reanalysis and downscale products. Which one I have to choose? Obviously, the question is try to use all you have, and then which is uncertainty. And this is something that I think we need to work more closely with the developers, because still we need to provide simple figures of which is uncertainty of the reanalysis and the derived product. The main handicap is that the uncertainty is very site-specific, so it's difficult to provide a regional value, larger scale or regional value for the uncertainty. So that's all. Next week, if you are in the Wind Europe conference, we will be talking about MERA-2. That will be like a complementation of this presentation. Thank you very much.
Well, thank you very much, Gilles, for this interesting overview of the use of ERA-Interim in the wind industry. So we are now moving to the last presentation by Lucien Wald. I will give you the presentation rights. Should be okay now. And you could share your screen, Lucien, please.
Do you see it now?
Yeah, it's fine. You can go. If you could, put it in full screen, it would be better. Yeah, okay. Thank you.
So the talk is on the assessment of daily solar irradiation that are estimated from ERA-Interim reanalysis and assessing this against ground measurements. MinParisTech is a school of engineers, and we are dealing with solar energy for many years now. The advantages of using reanalysis from companies and practitioners' point of view is that there is a worldwide coverage with the same method. So, as said already, there is consistency in the data, in the estimates. There is a large temporal coverage covering several 30 years or more. Access is quite easy because it's on the web. Usually it's for free now, and so there is no cost or low cost, which is something important for companies. One point I would like to say here is that the reanalysis do not assimilate irradiation measurements, contrary, for example, to air surface air temperature. Irradiation is fully modeled, so that means that it includes estimate of irradiation, includes the uncertainty of the model. The objective of this lecture is to propose an assessment of the quality of ERA-Interim, focuses on daily irradiation. Why daily irradiation? Because it's usually difficult to get measurements of irradiation. Hourly irradiation is you have only a few tenths. Daily irradiation you may get 100. The methodology is something which is quite usual. We collect measurements, we control them. We interpolate ERA-Interim estimates every 3 hours to the site of the interest by bilinear interpolation in space, and we compute daily irradiation for the site of the measurement. And then we compute deviation, measurements minus estimates. Sorry, it's estimate minus measurements. Excuse me. This map shows 113 stations that have been used in this paper from Boilet and myself, published last year. And so we have a merge of different networks. We have BSRN network. BSRN is baseline surface radiation network. They are 1 minute measurement, very high quality, and they are on here. There are something like 10 or 15 of them. There is a global atmospheric watch network with hourly values. Again, we have 10 of them. And most of these 113 stations are from good to moderate quality. Got from the World Radiation Data Center in St. Petersburg, most of the data, and also the Pirata network, which is a network for the station in the tropical Atlantic Ocean. I will focus on 2 stations, Rafah in Egypt, which has often cloud-free skies, and Camborne in United Kingdom here, which is a maritime climate with a lot of clouds. So this is a type of 2D histograms, or what can be called also scatter density plot, where here we have drawn the daily radiation measured by the station, and here the daily radiation estimate from ERA. Here you have a good alignment along the red line, which is the identity line, and you can see that the fitting line is very close to the, in green, is very close to the red one. So there is a very good agreement between the measurement and ERA estimates. You can see that the slope is 0.98, the correlation coefficient is 0.93, relative bias is very small, 1%, and relative standard deviation is 30%, which is usually very good for when you have estimates from model. So this is a very nice case, and now it's a standard case, which is the one for Camborne, and which is also most of the cases in Europe or South Africa, in Africa, except for the very dry climate. So here you can see that we have a large scattering of the data. Most of the values are low because it's Camborne, so it's high in latitude and it's quite cloudy. So we have usually low magnitude of irradiation. But what is striking is all this scattering here, which is too large. So we have a low correlation coefficient, 0.76 only, which is very low for daily irradiation. We have a bias, relative bias, which is large, 30%, and a relative standard deviation, which is very large, of almost 50%. The results of this wool study made by Boilet and Wald was that the wool over this 130 station, there is a slight overestimation by ERA-Interim. But what we observed was that was a large variation of the bias for the same climate. For example, we were having relative bias ranging from 2% to 17% for the Baltic area, while the climate, there is no so much change in climate. For France, running from -4 to 14%, and for Eastern Europe, -13. Eastern Europe means mostly central, southern part of the Eastern Europe, -13 to -5%. So there is a large change in bias, and this makes the use of ERA-Interim difficult for companies. And as a scientist, we were wondering why. So we took a closer look to the results. For that, we use what is called the clearness index, KT, which is equal to the daily irradiation measured at the ground, divided by the daily irradiation observed at the top of atmosphere for the same geographical coordinate and the same day, of course. So KT is ranging between 0 and 0.9. It's a sort of global transmittance. When the clearness index is close to 0, that means that this is very small. That means that there have been a lot of extension of the radiation, incoming radiation by the atmosphere, clouds. And when it's close to 0.9 or 0.8 or even 0.7, it means that it is clear sky. The advantage of the clearness index is that it removes the seasonality due to the Earth's orbit. It removes the effects of the sun position too. So I recall the graph I already presented for Camborne with the daily irradiation from the station and the daily irradiation from ERA. And this is how this graph appears when it is converted into clearness index. So same here, daily clearness index from station, daily clearness from ERA, and you can see now that we still have a very large scattering of the data, of the clearness index. Here we have a lot of points, the clear blue here, which are located in medium sky here around between 0.4 and 0.6. Here, which says that the sky is often cloudy, which is not a surprise. This is the climate of Camborne. But you can see that we have a very, very large scattering here. The correlation coefficient is very low, 0.3. The relative bias is 12%. For the irradiation, it was 13%. Relative standard deviation is 44. For daily irradiation, is 48. And so obviously we have a problem here. The problem is that mostly when the station is clear, ERA says that so station is clear means we are on the right of this line here, and ERA says that we have medium sky here. Stations say we are medium, ERA may say we are overcast, or may say as well that it's clear. Stations say it's overcast, ERA may say it's clear, or may say it's medium. So there is a kind of random behavior of radiation from ERA. So the conclusion of this study is that there is a bias and a large variation of errors in space, we have seen, and they are mostly due to errors in the modeling of the presence of clouds in ERA-Interim. ERA-Interim often predicts a cloud-free condition, while the stations say it is cloudy, and on the reversely, ERA-Interim predicts cloudy condition, while the stations say it's cloud-free. So this there is a problem in predicting cloud amount in ERA-Interim, which yield large error in predicting irradiation. The errors depend on the local climate, but they are hardly predictable, as we have seen, because we have this large scattering of bias and errors within the same climatic area. For example, the relative bias range from 2 to 17% for the Baltic area. This is not, the results were not new, and they are in agreement with previous studies. and the paper from Boile and myself was also dealing with MERA, and findings were similar. So as a conclusion for a company, as a researcher, I recommend to the company to not use reanalysis in solar energy. If companies want to use them, we suggest them to perform prior assessment of ERA-Interim in the specific areas they are targeting, making assessment against local measurements, and again to use the clearness index to better understand the limitation of ERA-Interim in this specific case. What we have seen is that in regions where clouds are rare, like in North Africa, ERA-Interim may be used for gross estimate of monthly or yearly irradiation. Again, we have a good agreement, and the correlation is very large, but the bias is why it is a bit low, is still varying in space. So our suggestion to companies who don't want to spend money is if errors to use satellite-derived database, such like the ERA-1 database, in which cover Europe, Africa, Middle East, and Southern America. It is for free. It's what is called a GEOS. Sorry, GEOS is a Global Earth Observation System of Systems, which gather all the system for Earth observing. And data core means GEOS, data collection of open resources for everyone. So it's stamp of quality and for free. It is an easy access from a website, and it covers 1985 to 2005, that means 21 years. Or we suggest them to use also CMSAF from EUMETSAT, which also derived from satellite Meteosat, which have free access and covers a large period from 1983 to 2015. These were bad news, and of course we are trying to be optimistic, and we were wondering if we can correct ERA-Interim for irradiation. So there are techniques which exist for correction, which are applied to other state variables like air temperature, wind speed, or pressure. And the difficulty in correcting errors for irradiation is that they are not predictable, so it's quite difficult to correct them. We have made an attempt into ECEM, and the next few slides will present these results. We have tested several techniques. I want built on that, and the most efficient techniques that were found is what is called quantile mapping applied to the clearness index. Our reference for the calibration set against which we will calibrate ERA-Interim for the period 2005 to 2014 is ERA-3 V5, which is derived from satellite, from Meteosat data, and resampled to the ERA-ECEM grid size of 0.5 degree. So we have 55 stations with daily irradiation from the World Radiation Data Center. Again, we have here Camborne and here Rafa that we have seen. Here is the result of the bias for ERA-Interim, so no correction at all. It's a reminder of the previous results. So we have adopted the form for the circle, means that there is the absolute value of the bias. The magnitude of the bias is less than 5 watts per square meter, which is 120 watt-hour per square meter, which represent approximately 3% of the mean of the measurement. And we have a circle when, in fact, the bias is very small. We have put triangle with up, which means that the bias is positive. There is an overestimation, which is greater than 5 watts per square meter, so a relative bias which is greater than 3%. When the triangle is down, the bias is negative and less than 5 -5 watt per square meter. So you can see from this graph that the bias is very often positive. There are more triangles with a peak up than the peak down. And there is on this, out of these 55 stations, 12 of them are with no bias. So now we are correcting the data with the techniques I mentioned. And this is the results where you have, we are using now the shape, again the circle, triangle, and we are also using colors. Let's begin with the colors. So the green means that now, after correction, the mean value, the absolute value of the bias is less or equal to 5 watt per square meter. This is what we call with no bias. Yellow means that the magnitude of the bias is comprised between 5 and 10, which is 3 and 5% in relative value, 3 to 6%, sorry. And the red one is that the magnitude of the bias is greater than 10 watt per square meter, relative value greater than 6%. So of course we'd like to have everything is green if there is if the correction is perfect. Circles means that we have no change. That means the absolute value of the change is less than 5 watt per square meter. Triangle down means an improvement in the bias. Triangle up, a degradation in the bias. So here, for example, that means that we have now in this German station, we have now a very satisfying value for the bias, which is low, and it was also low for ERA-Interim without correction. Here we are very satisfying results now after correction, and it represents a strong improvement compared to ERA-Interim without correction. So you can see now that we have quite a lot of green symbols, and there is now 22 stations out of 55 with no bias. Previously it was only 12, so we have a strong improvement. And the good thing also with this correction technique is that we have no degradation in bias compared to ERA-Interim. So we have an improvement or statu quo for all stations, so which is very satisfactory, and which means that ERA may be corrected the satisfactory, leading to a bias correction for most of the stations. Thank you.
Well, thank you, Lucien, for this interesting analysis. We now have a question and answer session. You can probably see them in the control panel, but I have put them on the presentation there. I'm going to reactivate the sound for the speakers, which should be done now. And maybe we could take first a clarification question maybe for you, Jill, which was, you talked about a simple and understandable metric, and apparently it was not clear for some of the people. Could you please clarify on this?
Well, I meant that when we try, within the wind industry, it's very common to use just the correlation coefficient, R2, as a metric of the quality of the reanalysis. Yeah, and this is something that we could say that is not the whole picture, but it's something that is very understandable by anyone. And the main constraint is when we used to validate the reanalysis products or downscaling products with observation that span over 1 or 2 years. So for the monthly correlation, probably sometimes it's not robust enough because we don't have enough samples.
Okay, thanks. There was another one specifically, or two indeed, specifically for you. So they are on the screen at the moment. There was one about something about the knowledge versus perception of climate change. Could you comment on this, please?
Well, when I mean the perception, it's probably it's a little bit outside the scope of the technical part, but it's more that in the wind industry we lack probably knowledge on what is the climate of the wind. We know very well the microsighting analysis of the wind conditions, but sometimes when we are dealing with the long-term reference, that is the main use of the reanalysis, and we see variability, and the industry and the users see variability, I think still we need to put a name to this variability, because sometimes the perception is that when there is anomalous error is because the data are wrong, and I think this is not the case. And in terms of climate change, I would say that obviously there are trends. Probably the trends in the winds are more evident in the extreme years. So for that we need probably more than 10 years of reanalysis. We need to span over at least 30 years to incorporate it. But at the moment, the climate change is not employed for the feasibility studies. We only look back in time, and as I said, in the wind industry, they don't like the trends and the change in the variability, and sometimes these changes or these trends are obviously based on natural variability or climate change signal.
Okay, thanks. I don't want to put you on the foreground, but there's a third one specifically for you, which was about the evidence of a systematic bias in wind speeds for ERA-Interim. Did you find any such systematic bias?
Not globally, no. It's not the performance of ERA-Interim, for example, in North Europe is great. It's excellent. It's for offshore. It's a great source of information. And then the regions where are much more complex, especially southern hemisphere, I think is something that I hope the new reanalysis will provide better data, better representation of the climate variability in the southern hemisphere. But for example, what we see in North Chile or northeast of Brazil or South Africa, it's different issues that probably is more related to, for example, in South Africa, it's more because there are very localized winds with thermal effects that are not resolved by the reanalysis, and even the downscale product still need to probably to go a little bit further than 3 kilometers. In Chile, North Chile, we saw that the ERA-Interim was very good in terms of prescribing the Pacific conditions, but for instance, the katabatic winds are not very well portrayed. This is an issue, what I say, regarding the very localized effects. And in northeast of Brazil is something that was an error, was something with MERA specific. So I wouldn't say that it is like ERA-Interim is always predicting more wind or less wind, because at the end we don't mind about if it's more or less wind. What we want is to know if the variability that you get from the ERA-Interim is the right. Not the absolute value. We don't use the reanalysis to get the absolute value of wind. For that, we need to downscale up to very high resolutions to get all the speed up factors. So.
Okay, thanks. I think we'll come back to you in a minute because there are other questions for you, but we can move maybe to another one which is not directly linked to ERA-Interim, as I understand, which is the one I'm highlighting at the moment. So where are we regarding storage capacity for solar energy? What is available out there and what in research? I think it's a broader question than what we're trying to address in this webinar, but maybe Lucien, you would have some elements of answer for this one?
Not that much. It's not my storage capacity is not my favorite domain. So especially to see, to my opinion, to my knowledge, sorry, the few I know, is that it's still in a research domain, most of them. There are some prototypes at one scale, but there is also, when I see here, I guess the question was on storage capacity, like batteries or like bodies that may change phase and store heat. But there are also some other questions or approaches using what is called smart grid or smart cities, where you can store electricity in some way, not storing it, but in some way making it use in places where there are no electricity. So it's not storage, it's efficient use. But I'm sure that you have better answer, Laurent.
Yeah, I'm not a specialist in storage neither, but what I know is that there are many pilot studies and proof of concepts developing currently, linked to especially the question of smart grids and development of small-scale networks disconnected or separated from the national networks, for instance. I know that there are already operational applications with large-scale batteries. For instance, we have one such example in La Réunion Island in the ocean, in the Indian Ocean, with a 1 megawatt battery, in which there are tests, and it's a prototype to see how the battery could deal with the intermittency and the variability of wind and solar energy production. I know that one of our subsidiaries, EDF-EN, has been appointed for the development of a storage system in the UK, where PV is developing very, very fast. So it's something which is indeed developing quite quickly, but it's still in its infancy, and there's still a need of really strong research, especially because the technology is not mature enough, and the costs are very high still. So research is still necessary, but I think it's going to move very, very fast. So Gilles, I'd like to come back to you. I think we'll have maybe five more minutes to answer the questions. There are many coming now. Can you see, Gilles, if you see this one, can you highlight some points on the vertical wind shear in ERA-Interim, if you have looked at it? Did you?
As I said, we don't use the reanalysis for site assessment. We use it as a long-term reference. I think the wind shear is information that we need to get it from downscaling products, and again we see from our downscaling data using ERA-Interim, for instance, that the wind shear is very good representative for example, for the offshore in the North Sea, which is a very tricky region because it's very stable atmosphere. So the profiles are quite strong. So it's very important to get it right. So we see that the downscaling with ERA-Interim in that region, the shear are more or less corresponds to the reality. But again, we in the wind energy market we face such a variety of situations, sites, regions, because the location of the project, because the climate, because the complexity due to the topography, the roughness, because many local effects that it's difficult to it's not possible to get a proper answer. What we see in general with the reanalysis, and in particular with the ERA-Interim, but this is something that we see in general, is that the low-level jets are too high. So sometimes that's why we probably we don't get the intensity of the low-level jet at the right position. But as said, we cannot use the reanalysis as if they are, because the resolution, 70-kilometer resolution, is not enough to get an absolute value of the wind conditions or shear for a project.
Okay, thanks. I think we'll take the 3 last questions and try to give a quick answer because the time is over. So I think this one is maybe for Hans, if you have an opinion on this. So can you suggest us for using ERA-Interim to answer questions specifically concerned with future climate change scenarios? And the example which is given is that Scandinavian countries are interested to know how winter icing parameters will likely respond in the future. So my understanding is that the question is, can we use the for almost 40 years of data in ERA-Interim to assess the viability and to get some information about the potential evolution in the future?
Well, that's a very difficult question because, of course, ERA-Interim is a reanalysis, and it makes use of all the observations in the past, and of course we don't have the observations for the future, so we don't know exactly how it's going to evolve. And yeah, you could do several things. You could try to look at the climate in ERA-Interim and see how it has evolved over time, and do a kind of extrapolation. But you have to do it in a very careful way, and that's not easy. If you want to do projections, for instance, model projections, then you don't have observations, and then the model bias will be not corrected anymore. So those are all very difficult questions. There will be in C3S there will be a tender on projections, which should address these kind of questions.
Yeah, and I could add as well that in the current projects which are developed in the frame of C3S, so in the Copernicus framework, there is one of the sectoral information system proof of concept, which is called Clean for Energy, which has some case studies, and one of them is specifically dealing with climate projections for the agroforestry sector in Norway and Finland. And so in the Scandinavian area, and there might be some information coming from this project. So last but one question, which is emphasizing the fact that Lucien concluded that maybe ERA-Interim should not be used for personal applications, especially for solar applications. And so one of our attendees is curious about the response you could bring to this point, Hans and maybe Gilles, but Hans maybe first.
Well, of course, it depends. I mean, some areas ERA-Interim is better than other applications. I mean, for radiation, which although, as I explained, that 40 VAR, so the system that assimilates, that uses all the data and comes up with a better analysis given the short forecast of the previous analysis and corrects that, is multivariate. So although observations for irradiance are not being assimilated directly, there will be an effect from temperature, humidity, etc. observations on the analysis. But of course, it's indirect, and therefore that will likely not be the best. The product with the best quality, as we have seen in the presentation. But there's many other applications, many other areas where ERA-Interim is much better. And of course, it also depends on the parameter, whether a small scale variability of the parameter itself. I mean, radiation, that must be very local. And so that is inherently also more difficult to analyze. And ERA-Interim, it is a real, if you look at ERA-Interim fields, they are basically kind of the free hourly 80 kilometer or 100 kilometer area average. So it depends. If you are very, if you're very specific, then for one interest, one local parameter, then of course an ERA-Interim will have problems. But for other cases, it will be quite much better.
Okay, thanks. And I could just add as an ECEM project participant that in the frame of this C3S project, we are working on the climate parts on bias adjusting ERA-Interim with observations, with ground observations, and that there's field for improvement, even if the direct output from the Reanalysis are not always of a sufficient quality for some application. There are ways to improve them by some bias correction techniques, and I will, in the conclusion, give some information about a forthcoming workshop in which you could learn more about that. Maybe we could take a last one, even though there are some other questions arriving now, but time is over, so we'd just like to take this last one, which again is for you, Hans. So you presented the new Reanalysis, ERA-5, and the question is that do we already have some kind of an overview of the improvements of ERA-5 versus ERA-Interim?
Well, ERA-5 is still in production. I mean, we need more than a year to finish it. But there is one publication in the ECEM newsletter. It's not the latest one, but I think the previous, which is a one-page overview of what is new in ERA-5 compared to ERA-Interim. It doesn't give, so it's purely specification of model resolutions, and but it doesn't give details exactly what the differences are. But in principle, everything which has happened at ECEM over the last 10 years since 2016 in model development, that's in ERA-5, because ERA-5 uses the same model cycle which is used for our operational forecasting system, although at lower resolution to keep it affordable.
Okay, thanks. And we can remember that we can remind that so ERA-5 will produce some first data end of this year, early 2017, and that it will be completed by the end of 2017. So more information is going to come then. Thank you. We'll take a very last one because it's interesting. I didn't put it on the screen, but the question is for you, Lucien. And it is for solar assessments. Industry often demands sub-daily time series, 3-hourly or even hourly. Did you look at such frequencies in ERA-Interim in your alternative products?
Answer is no. We do not have enough. Okay. The purpose of our work was to see if we can use, or if companies can use ERA-Interim or MERA in order to find out for appropriate sites for seating. And so we wanted to see if the bias in ERA-Interim was variable or not. And we focus on daily irradiation because then we can have a lot of data, and we do not focus on hourly values.
Okay,
so do not
thank
have
you.
answer.
Okay, thank you. So I think we need to close here because we're over time, but there were quite a lot of questions. I would like first to thank all the speakers for their interesting presentations. Of course, I'd like to thank you all participants for your attendance and your questions. We reached 45 participants, which is good, I guess, for such a webinar. So if you'd like more information about the ECEM project we're working on, you have on the screen the web address. You just need to type Copernicus and ECEM and you will find it easily. This webinar was co-organized by the World Energy and Meteorology Council with the web address you can find, and you can meet us also on Twitter with especially the left hashtag C3S_energy. And by the way, it's a good way to inform you. There will be a save the date and a flyer issued in a few days. But the two energy projects in Copernicus will organize a joint symposium in next February. It will be in Barcelona, and so there will be more information circulating around in the next days, and especially on the Twitter account. So once again, thank you everybody for your participation, and we hope to have opportunities to meet you in person or in such kind of events that we will probably organize again in the future. Thank you everyone, and have a good day.
You're welcome.